Hi everyone. So in this first series of this session, we'll be talking about and showing how we have set up a fully automated CI/CD pipeline using AWS CodePipeline and CodeBuild. As you know, currently AWS Code Deploy not supporting the deployment for EKS clusters, but ECS yes supporting. But hopefully in the future they will be releasing for EKS support also soon. So I'll be showing you how that I've configured these YAMLs and the code build, the environment variables, how to inject the variables to the code build environments, and the parameters and so on. So the next slide I'll be showing how the simple infrastructure of this setup and how these are working, especially the security level, like how I'm going to assign the roles to execute kubectl commands and so on. So let's go and see the next slides. Hi, let's see the infrastructure of today's pipeline setup. So this is very basics, okay? So you can see we have a simple AWS code pipeline, and inside that we have we are using the code build, since code deploy is not officially supported for EKS, and we have EKS cluster and our container repositories today, ECR, Elastic Container Registry, which is AWS services as well. So it's really easy to connect with IAM roles, all the resources inside the AWS cloud. And the scenario is like basically today I'm the developer and I have a repo in the GitHub repo. So I'm going to change some changes to my code and see how it's automatically triggered from the code pipeline. And in code build, we have a set of instructions to run, execute, and it will basically build my container, a demo app, and it will push the artifact to the ECR. Then from Kubernetes deployment, it will pull that container image and it will do the Kubernetes deployment. So this basic simple, but inside that there are a lot of questions that everyone's asking, like how these IAM roles are connected, how these AWS services and the Kubernetes cluster is connected. So let's go and see one by one in this session. Demo pipeline for this video. So basically I'm using only the code build part because as I mentioned before, the deploy is not officially support for EKS. Here basically I have connected my GitHub repo and there's a demo application there. You can find that GitHub URL in the below, so you can test your own as well. So let's go to the build. I want to show a few things which are really important to understand. So here, let's start with the my code build. Let's start with the environment variables because I'm injecting few of the environment variables such as AWS region, repository, repository for the ECR repository, and the kubectl role and EKS cluster name. So about these roles, I will be explaining further. So this is the main, like 4 variables we're going to inject. Let's go to the code and I'll show you where we are using those things. And here you can see I'm using these variables here, here, and here, and here. So let's see in the demo later, and I'll be explaining this file as well later. Okay, so this is the basic view of the code build part, but let's go to the code build project and let's deep dive about our project. So this is one of the testing ones, you can leave it. And here okay, so I was keep testing because that code which I used to demo previously, like I think more than a year ago, that's pretty old and I had to change a lot of things, and don't worry, the code is updated now. And here I will show the environment. This the environment I'm using the basic Linux, AWS Linux version 2, and the latest version here. And this service role, this is something we have to talk, because when we're executing this code build, this is the service role it's going to access, such as other services like S3 and Cloud Workflow Logs and so on. So in our scenario, we have two of the services, which is, one is the ECR, Elastic Container Storage repository, container repository, and the one is the EKS cluster. So for accessing the EKS cluster, as you know, the AWS config maps we have patched with one of the roles to access the Kubernetes cluster. So later we will go to the Kubernetes part. Let's first see what are the two services we are going to access through the service role. So one is the ECR, and other one is this role, basically a kubectl role here. Those are two services. So in the environment, I want to show you that. Let's go to the role. And so here I have ECR full access, because the registry, we are going to build the container here, and we're going to push the container image here. So we need the read-write access both. And here, this is the part where we are going to use assume this role through this service role, the code build. So basically, this code build role will be assuming this role. Basically, we are using SGS assume, so it will be assume the role first, then it will return with some temporary secret credentials. Then it will helps to access the Kubernetes cluster. So this one I will show in the build spec YAML later. So let's go to the code build again and discard that. Okay, and let's go to the build spec. So here my code structure is a bit different, because I want to keep a good clear structure. So all the Kubernetes channels here, all the AWS resources here. So that's why I'm using that extra folder as AWS, then go to build spec. So we are using this build spec to execute our deployments. Okay. So basically, in first, initially we are just logging to the ECR using the other IEM roles, and I'm downloading the AWS IEM Authenticator. So basically, Amazon EKS use this IEM Authenticator to authenticate with your Kubernetes cluster. So this basically helps to authenticate the IEM and the Kubernetes cluster. So before going further, I think it's better I will give a small explanation about how this is working. Structure of how this is the cluster authentication happening. So basically, if I'm executing kubectl command and parse Amazon Web Services identity, then it's verify with Amazon identity, which we call as IAM services, and then it's returning back to the Kubernetes API. Then in the RBAC, it's authorized the identity, whether it's checking is authorizing or not. Where we later where I'm going to show the config maps, where we patching our config maps with these IAM roles. Then it will get the return as its actions allowed or denied. So basically, this is the basic infrastructure of these authentications, and I'll be pasting this resource URL, which is AWS documentation. You can read through the description. View my current config map. and I can show you that IEM role which I'm using to execute kubectl commands. Let's view our current config map. Okay, so you can see my config map is there is AWS auth, and let's get that. I can see here, right? So this is my IAM role, which I'm patched to the EKS, the Kubernetes config map, which I mentioned before. So basically here, what happens is we are giving permission to this role to interact with the EKS cluster and execute our kubectl commands. So this is the basic view of the config map. It's assuming the role. So as I mentioned before, and according to our demo, that the AWS CodeBuild IAM roles have access to assume the kubectl role and get the temporary credentials and access the AWS EKS cluster and execute the commands. So let's see how this. So as we know, when we accessing a Kubernetes cluster, we have to config the kube config. So it's already done in the our build spec YAML, and let's see how that is. I did AWS IEM Authenticator already, so basically it's downloading, and after that the kubectl file is downloading, and then make sure the versions are correct here. If you're maintaining a good configuration, so make sure that you have update these accordingly. The latest version, so always you can find it in AWS documentations. Then we are creating a variable called tag, because the repository name is already providing the environment variables, and we have to create a temporary tag name, which will be the container tag to push here in the Docker push command. So here you can see the content image. This environment variable name you see by here, which will replace with the new container always, and always the image pull policy is always, so it will pull the container always, and it's updating. Then we export environment variable name called kubeconfig, so that's here. So after that we are building the Docker image. There's a Docker file here, and after that, what will happen is pushing this latest Docker image to the ECR. Here's the interesting part. Remember that our EKS kubectl role, these are in here. So what will happen here, that CodeBuild service role will assume this role, and it will get the temporary credentials, and it will assign to these variables, and it will create a default profile for AWS default profile inside that CodeBuild instance, and it will update the kubeconfig with this cluster name, which we provided in the environment variables. Then it will apply, because it's already replaced here with the container new tag and the image. So it will apply the deployment. So this is the basic EKS CICD setup we can do with build spec. It depends on the engineer who needs the requirement. So for example, I have done before, like accessing secret manager variables to give the application, inject the database credential to the Kubernetes pods. So it's same thing you can done by here. So basically it will access the secret manager and get the permission. So basically don't worry, this is a basic one. The next EKS CICD setup will be intermediate one with using multiple accounts, multiple OUs, and different services we can test. It's up about the demo app, how it's working. So basically there are two pods running, two replicas basically. So basically, there are 2 pods running here, and I'm using ALB ingress controller to expose these pods to access to the web. And let's check the URL of that. Okay, let's open this in the browser and see our running this application running. So just printing some words. So this is version 1. We can change the code in the code that will change this one to version 2.0 and see how this pipeline is triggered and how the deployment is happening. And let's see the demo. Message we were checking. So what I'm going to do is I'm going to change this version to version 2.0, and I'm going to save it. Now there are a few things to comment because I added these roles, the JSON files, which you can later use in your own testing setup. So I'm going to commit my version to change. Commit. Then you can see here my feature branch is CICD Demo with rules. Okay, let me push the changes. Create a pull request from our feature branch to the development branch. So, okay, you can see the changes. Okay, see the V1, so it should be replaced with V2. And create a pull request. Version 2 demo. Okay, let's assume another person reviewing your pull request and merged it, but as a demo, I'm just showing it. So let's go to the code pipeline, and the deployment is going on. Since it's a small one, it won't take much time. It will take a few seconds to get the logs here. Currently see that it's downloading the AWS IEM Authenticator and kubectl, and now it's Docker build is going on. I'm going to check the changes of my pods. So let's wait till, okay, you can see new container, this one container, so new pod. Okay, there are 2 pods are creating now, and all pods are terminating. So basically new pods are running, so we can run. Next video, this will be a setup of 3 application AWS accounts. Like we are going to use dev, UAT, and production. These are separate accounts, and there's an account for security and infrastructure. So in infrastructure account, we are going to store our pipelines and related resources and our any other third-party deployment tools and our registries, repositories, and so on. In the security account, we are going to store our logs, and we are going to store our KMS keys and our secret managers and SSM parameters. And let's see how we are going to access those secret manager resources to access RDS instance in our applications using all these accounts. And especially, I mentioned before that I was explaining the code build. I showed that you can build using VPC. So basically, we are going to use VPC peering and endpoints to access these all the services together. And it's not complicated, but this is the production. I would say like production ready setup where all the best practices we can use. If you have any suggestions and improvements, just please put comments as below, and we can improve those things. So thank you very much, and have a nice day, and make sure be safe, and stay home and wear a mask always as possible. Okay, see you in the next video then. Thank you. Bye bye.